So why do we worry about climate change? We don't really worry about the impacts of climate change, of which there are many, and I'm going to start talking about the impacts of climate change on nature. If you drive south through Europe or North America, the further south you get, you meet different plants. And the reason is that some plants can't tolerate cold, some plants can't tolerate heat, some plants are very drought resistant, some plants are very good with floods. So if different plants grow in different climates, then you would expect that if climate changes, different plants would grow as well. And it's not just the direct effects on those plants, there's also a lot of competition between plants for resources. So even if a plant itself is pretty robust, it may still be outcompeted because of climate change by other plants. And it's not just the plants that matters, but also everything that feeds on those plants or everything that feeds on the things that feed on those plants that would be affected. And these effects are rather large, and that is shown in this particular graph. This is not about individual plants or individual species of animal. This is about biome changes. A biome is a collection of plants. So a rainforest would be a biome, or a savanna would be a biome. And what you're looking at here is the agreement between models that it would be a biome shift, that the rainforest would be replaced by savanna, or the tundra would be replaced by boreal forest. What you see is actually that in large parts of the world, the impacts of climate change on nature would not be one or two different plants appearing. No, this would be a wholesale change in the biome. This would be a complete change in the landscape. This would be the rainforest being replaced by savanna, or the tundra being invaded by forest. This is a complete change in the way things look and feel. And essentially it is almost everywhere. You can be a little bit more structure on this than just say things will be different. Essentially, as a rule, specialized plants and animals are likely to lose, and marginalized plants or animals either will thrive or will go extinct. And the reasons for this is probably better illustrated with an example. Here you're looking at Edelweiss. Edelweiss naturally grows high up in the Alps. The reason that it grows there is not because it particularly likes it there. It can get very hot, it can get very cold, you can get covered in snow of 2 meters deep. The reason that Edelweiss thrives there is that because no other plant does well under these circumstances. And Edelweiss cannot on its own grow in the valleys because it would be outcompeted by other plants. Now, if the climate were to change, where should Edelweiss go? If it gets too hot or too dry, where would it go? It can't travel through the valley, it can't get into the German plain because there's other plants growing there, and Edelweiss can't compete. So as climate change encroaches on the Alps and the natural habitat of Edelweiss is disappearing from the Alps, it essentially needs to jump all the way to the mountains in Norway to find again a suitable climate, and that is simply too far. There's small seeds that are blown by the wind, but not as far as Norway, and that means that a plant that is specialized in a very particular niche that does well under very particular circumstances, if those circumstances disappear, the plant will disappear with it. Climate change will simply drive species like this to extinction. So other impacts of climate change, climate effects. Climate is not just about warming, but it's also about changes in rainfall patterns. And that means that drinking water will be affected, irrigation water will be affected, cooling water will be affected, and there will be in some places more droughts, in other places more floods, and in some places even more droughts in summer and more floods in winter. And again, this is widespread, it's basically everywhere. What you're looking at here is another graph, another map from the IPCC, very unfortunate color coding. What we're looking at is the 100-year flood, the flood that now has a probability of occurring of 1% per year. And in blue, the flood frequency increases. That means that the flood that now, the amount of water that now comes down your river once every century would then become twice a century, every 5 years, even every 2 years. And you see there is a lot of blue. This is where floods are getting more frequent. In red, there's a more positive situation where the flood actually becomes rarer. That the 100-year flood, the flood that now occurs every year in the very dark red, the flood that now occurs every century in the very dark red would occur every millennium. Now, this is good for flooding, of course, if you're worried about flood risks. This typically means that actually things are getting pretty dry and droughts are getting worse as well. But the takeaway message from this graph is really that only in most places of the world you would see fairly drastic changes, and it's only in places that are pretty dry, where there are no floods at the moment, that you wouldn't see much change. But basically, the flood and drought regime would change everywhere, and fairly drastically as well. There's other impacts of climate change. Climate affects the consumption of energy. If it's warmer in winter, you need to spend less money heating your own home. If it gets warmer in summer, you need to spend more money on air conditioning and cooling. Climate affects tourism. We go to Spain on holiday because the weather is nice, but actually it may become too hot there in July and August. People may instead go to the Baltic Sea or something like that, or the English South Coast instead of traveling to Spain and Greece. Climate affects construction. If it's very hot, people can't really work in construction. If it's very cold, people can't really work outdoors either. Climate would affect transport. Floods may disrupt traffic. High winds may close airports, and so on and so forth. Climate also affects labor productivity. This is probably a bigger effect than the other ones. The reason is simple. If you're outdoors, if you're doing heavy work, it's simply difficult to work. We are mammals. No, we are warm-blooded. We're also mammals. We are warm-blooded animals, and that means that we need to keep our inner organs at 37 degrees Celsius. That is when they work at their best. If it gets too cold inside your body, you get into health problems and you may quickly die. If it gets too hot, then your organs also start breaking down and you die. Now, keeping your inner body at that 37 degrees isn't a big issue if you're young and healthy, but it does mean that you get tired more quickly, because essentially if it's hot outside, then essentially your body needs to work to keep yourself cool by sweating in first instance, and if that doesn't help, you simply need to slow down, and otherwise you overheat, and that means that you simply can't work as hard when it is very hot. People typically feel very tired during heat waves, and that affects the labor productivity if you work outdoors. Now, our cooling system works through sweating, through the evaporation of water, and that means what matters is not so much the temperature, but the so-called wet bulb temperature, which is a combination of heat and humidity. If you're in a very humid area, then your sweat cannot evaporate because the air is saturated with water already. So what matters is the wet bulb temperature. temperature, and here you're looking at a scenario of changes in the bed bulb temperature. And then here are the implications of what does this do for labor productivity measured in person years per kilometer per year lost due to the additional heat. And this is concentrated in two places where population density is large and where it's hot and humid. This is a different study but roughly the same result. This is the change in the ability of the body to do work after climate change. Two different scenarios, one mild climate change scenario, one severe climate change scenario. This is given for countries in the European Union, and then here the scale changes and you look at the same thing for countries outside of Europe. And the worst numbers that you see here are for Southeast Asia. Where it is already very hot and where it is already very humid and where a lot of people work in conditions that are not air conditioned. And if you keep all those things as they are today, then you would see a drop in labor productivity for the severe scenario that is 30-35%. Now, to put things in context, your weight is roughly proportional to your labor productivity. So a 30% drop in labor productivity means, all else being equal, a 30% drop in income. So these are large numbers, very large numbers. Now, this is about the ability of a worker's body to do stuff. But older people also need to keep their inner organs at 37 degrees. And if you're older, even if you're not working, you have difficulty you simply difficulty keeping your body cool. Your body needs to work harder, you tire out, and so on and so forth. If you're older, if you have cardiovascular conditions, if you have respiratory problems already, then heat stress may kill you. Similarly, we need to keep our body at 37 degrees also when it's cold outside. That also imposes a shock on the body, and particularly on the very young and the very old and people with underlying cardiovascular problems. So cold stress would become rarer if the climate warms. And it's not just the cold stress that matters. Very few people actually die of cold exposure per year. That's very, very few. A lot more people die of heat stress. What we also see is that during winter, people spend more time indoors and spend more time closer to other people. And that means that in wintertime, diseases like the flu are much more prevalent. And in Europe, if you're somewhere north of Paris, then probably winter deaths are much more common than our summer deaths. And in those places, the reduction in cold-related diseases, mostly flu, outweighs the increase in heat-related diseases. In Europe, if you're south of Paris, actually it's the other way around, and you would see a net increase in deaths because of climate change. There's vector-borne diseases, I'll talk about them later. There's also issues with water quality and food quality. Essentially, we refrigerate our food so that it doesn't spoil. Of course, if it's warmer, then food spoils faster for the little time it spends outside of the fridge, and so on and so forth. So there is this long list of impacts of climate change on health, and it's not just death that matters, but it's of course also just people getting ill and not feeling very well and not being able to work. The list of climate change impacts is long and diverse.